Hello everyone, welcome back to our data science journey. Today we dive into the backbone of machine learning and data science. I'm talking about probability. I know what some of you might be thinking, oh no math. But trust me, super simple, intuitive, practical. Probability is not just about flipping coins. It's not just about rolling dice. It's about understanding and quantifying uncertainty. In the world of data, uncertainty is everywhere. Will a customer click on an ad? Will a transaction be fraudulent? Will it rain tomorrow? Probability gives us a framework to answer with degrees of confidence. Why is this important for a data scientist? Almost every ML algorithm is built on probability. A house price model doesn't give one number. It gives a range of possibilities and likelihoods. That's probability at work. It helps us understand our data. It helps evaluate our models. It helps make decisions when outcomes aren't guaranteed. It is the language of uncertainty. Without probability, you're flying blind, guessing instead of predicting. It's the difference between analyst and true data scientist. Imagine a recommendation system for e-commerce. How do you pick the next product to show? Calculate probability a user will like or buy it from past behavior, and from behavior of similar users. That is pure probability, or a self-driving car. The AI calculates probability another car will change lanes, calculates probability a pedestrian will step into the road. These are real-time calculations with big impact. Understanding probability is your first step toward building intelligent systems. In Day 8, we'll break down everything you need to know. Start with the basics. What probability means. Explore different types of probability. Cover the fundamental rules. Tackle Bayes' theorem in an easy way. Then get hands-on with Python code. By the end, probability won't be scary. It's a powerful tool. A superpower for data scientists. Grab your coffee. Open your notebooks. Let's get started. So, let's start with the basics. What exactly is probability? At its core, probability is a number between 0 and 1 that represents the likelihood of an event occurring. A probability of 0 means the event is impossible, while a probability of 1 means the event is certain to happen. Everything else falls somewhere in between. For example, the probability of the sun rising from the west is 0, while the probability of the sun rising tomorrow is very, very close to 1. Now, there are a few different ways we can arrive at this number, and these are what we call the types of probability. Theoretical, experimental, subjective. The first and most common one you learn in school is theoretical probability. This is based on pure logic and reasoning. Theoretical probability works when all possible outcomes are equally likely. The classic example is a fair six-sided die. What is the probability of rolling a 4? 1, 2, 3, 4, 5, 6, and only one of them is the outcome we want, which is rolling a 4. So the probability is 1 divided by 6, or about 0.167. We didn't actually have to roll the die to figure this out. We just used our knowledge of how a die works. This is useful for games of chance for setting up basic assumptions in our models. It gives us a perfect, idealized baseline to compare against. It's the what should happen in a perfect world scenario. Next up, we have experimental probability, which is also known as empirical probability. This type is based on experiments' observations from real-world data. Instead of calculating what should happen, we look at what has happened. Let's go back to our die. Suppose we roll it 100 times and we get a 4 on 20 of those rolls. Our experimental probability of rolling a 4 would be 20 divided by 100, which is 0.2. Notice this is different from our theoretical probability of 0.167. This is super important in data science, because we are almost always working with observed data. We analyze past customer data to find the probability that a new customer will churn. We don't have a perfect formula for that. We rely on the data we've collected. Finally, there is subjective probability. This one is a bit different. It's based on an individual's personal judgment, experience, or opinion. There is no formal calculation or experiment involved. For instance, if you ask a seasoned stock market analyst the probability that a particular startup will become a billion-dollar company, their answer will be a subjective probability. They are using their years of experience, their intuition, and their knowledge of the market to make an educated guess. In data science, this might come into play when an expert helps set initial parameters for a model, or when deciding which features are more likely to be important for a prediction, especially when data is scarce. It's about leveraging human expertise. Now that we understand the different types of probability, let's talk about how we can combine them. There are two fundamental rules you absolutely need to know: the addition rule, the multiplication rule. These rules help us calculate the probability of more complex events. Let's start with the addition rule. This rule is used when we want to find the probability that either one event or another event will occur. Think of the word "or" as your keyword here. The rule is P of A or B equals P of A plus P of B minus P of A and B. This formula is for events that are not mutually exclusive, meaning they can happen at the same time. Let's use a simple example. Imagine you have a deck of 52 playing cards. What is the probability of drawing a king or a heart? We know P of king is 4 out of 52 since there are 4 kings. We also know P of heart is 13 out of 52 since there are 13 hearts. But we can't just add them together because we would be double counting one card, the king of hearts. This is the P of A and B part. The probability of drawing a card that is both a king and a heart is 1 out of 52. So, using our formula P of king or heart equals 4 over 52 plus 13 over 52 minus 1 over 52, which is 16 over 52. If the events were mutually exclusive, meaning they can't happen together, like rolling a 2 and a 3 on a single die roll, the formula simplifies to just P of A or B equals P of A plus P of B. Next, we have the multiplication rule. This rule is for finding the probability that two events will both occur. Here, your keyword is AND. The rule is P of A and B equals P of A times P of B given A. This second part, P of B given A, is the conditional probability of B happening, given that A has already happened. We'll talk more about conditional probability in the next section, so don't worry. For now, let's focus on the simpler case where the events are independent. Independent events are events that don't affect each other. For example, flipping a coin twice. The outcome of the first flip has no impact on the outcome of the second flip. When events are independent, the multiplication rule becomes much simpler. P of A and B equals P of A times P of B. Let's use an example. What is the probability of flipping a coin and getting heads twice in a row? The probability of getting heads on the first flip, P of A, is 0.5. The probability of getting heads on the second flip, P of B, is also 0.5. Since these events are independent, we just multiply them. 0.5 times 0.5 equals 0.25. So there is a 25% chance of getting two heads in a row. This rule is crucial in data science for things like calculating the likelihood of a sequence of events, which is very common in user behavior analysis or time series forecasting. We briefly touched upon this in the last section, but let's dive deeper. Conditional probability is one of the most powerful and practical concepts in all of probability theory. It's all about updating our beliefs based on new information. The question it answers is, what is the probability of an event B happening, given that event A has already occurred? We write this as P of B given A. This idea is at the heart of how we learn from data. Every time we get a new piece of information, we can update our probabilities and, as a result, make more accurate predictions. This is fundamentally what machine learning is all about. Let's use a very practical example. Imagine you work for a streaming service. The overall probability that a random user will cancel their subscription in a given month might be 5%, so P of cancel equals 0.05. This is our baseline. But what if we have more information? What if we know that the user did not watch any content last month? Let's call this event inactive. Theory is great, but as data scientists we need to apply concepts in code. Python's scientific computing stack makes this easy. We'll mainly use two libraries: NumPy for basic probability calculations and generating random numbers, SciPy for working with complex probability distributions. Let's start with a simple example. Simulate rolling a fair six-sided die 1,000 times. Find the experimental probability of rolling a 4. We can do this with NumPy. Generate random rolls with np.random.randint 17 size equals sign 1000. That gives an array of results. Count how many times 4 appeared. Divide by 1000. np sum rolls equals sign 4 1000. You'll get about 0.167. Increase to 1,000,000. The result gets even closer. This is the law of large numbers. So, how does all this theory and code translate into real-world data science projects? Let's connect the dots. The concepts we've discussed are not just academic exercises. They are the engine behind many of the applications you use every day. Let's take fraud detection, a critical application in finance and e-commerce. A model doesn't just say fraud or not fraud. It calculates the probability that a transaction is fraudulent. Next, consider recommendation systems, the heart of companies like Netflix, Amazon, and Spotify. We have covered a lot of ground today. Basic definition of probability, powerful applications in the real world. Probability is not just a branch of mathematics. It is a way of thinking, a framework for reasoning about an uncertain world. For a data scientist, an invaluable skill. Move beyond simple deterministic statements, embrace the nuance and complexity of real-world data. Embrace probability. Don't just learn formulas, build intuition. Thank you. See you in the next session.